Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Jeff Haynie, who is the founder and CEO of Pinpoint. Jeff Haynie, welcome to Maintainable.
Thank you.
So given your experience in the industry, what do you believe are a few common characteristics that a software application is being well maintained?
I think probably a couple of things from my perspective probably is one, if the interface boundaries or API boundaries are pretty clear, software that's hard to maintain, it's not really clear what the software is doing, and it's hard to unit test it, it's hard to break it down and easily understand the different parts that are moving. Most software, especially as it scales, gets pretty complicated. So trying to boil it down to smaller and smaller units of work, and that allows you to then test interfaces, write unit tests, and frankly understand what it's doing. Usually that's a good sign for me.
And you touch on like API. I'm assuming you're not just talking about building an API in your application, but the API within the application itself.
That's right. It's just sort of more of the interface boundary, and whether that, that's obviously a programming term in addition to sort of a specific language. So I mean more in the sort of abstract programming term, API or interface boundary, or kind of whatever divides sort of the application into smaller units to work, and however you interface with it. Not necessarily it has to be a third party or even a physical API itself, but just how a developer sort of organizes their application or their business logic, how they test it, how they can sort of interact with different components. Sometimes you have a lot of reusability in application, and or you have lots of different pieces of the application have to come together to be assembled. And so clearly having different boundaries that help you understand what's happening there usually is a sign of good maintainable code. It's not always perfect, because the applications over time evolve and those things change. And that's where refactoring or sometimes even full wholesale rewriting becomes important. But I typically find when there's problems or things that become repeated bugs, which usually is a sign of maintainability problems, it's usually because the developer didn't fully understand kind of the piece, and they weren't able to sort of boil it down to that smaller unit of work. And so they were fixing kind of maybe one part of it, and that maybe broke or made another part brittle.
You touched a little bit on like unit testing as an area. Do you have strong preferences or opinions on how much unit testing an application may have, or different types of automated testing?
It's a real hard thing. I think it's sort of a case-by-case basis. I mean, obviously, you could sort of say all unit testing is great, but I generally disagree with that, because you can often find yourself, writing unit tests that give you a false sense of security, or you're testing things that are outside your boundary, like, usually leave it up to the team and to sort of understand what the right boundary is. And usually the team sort of generally knows, if they feel very confident about their software or not. Oftentimes unit tests can lead you to believe that, oh yeah, everything's great because we wrote unit tests, and then it falls down in production. And vice versa, right? I mean, I've seen projects that are very, very well maintained, have very, very few bugs, and have no unit test. So I don't think I'm not very religious about it. I think there's a right and a wrong, and that's highly dependent on the team and the software and sort of the context that they're working in.
Right. Do you often use the phrase or the metaphor or technical debt often in your world, or is that something? What is your current take on it?
We do. And again, we've tried ourselves to come up with what sort of how you define technical debt, if you were to sort of, because it's one of those words that everybody sort of knows what it means, but nobody can kind of define it. It's sort of like an elusive word. And so I think you sort of know it when you see it, like a lot of things, but certainly technical debt. I sort of think about technical debt or all the sort of past sins that you've made that you haven't yet been able to clean up. And often, like development teams consciously say, we're not going to fix this right now. We sort of have to live with this sort of debt. We know it's something that if we had unlimited time and energy and resources, we'd fix it right away. And we even know how to fix it. But you sort of have to live with it, because sometimes you just sort of have higher priorities or more impending things that you have to work on.
Do you believe that there's some common conversations that software engineers are having with other stakeholders where they might bring up the topic of technical debt and maybe in an ill-advised way?
Well, I think it's sort of one of those things. Back to my previous sort of way of characterizing it, it's a hard thing to sort of to product people or business people or other stakeholders to sort of quantify. Number one, so there's always this sort of elusive technical debt. We always talk about it. It's also one of these things that we created, right? So it's sort of a self-owned, self-perpetuated problem that sometimes get foisted on other people as part of thinking about priorities or thinking about how we're sort of taking longer to do something or we need to go really refactor something and sort of stakeholders don't really understand the benefit or why we would do that. And as we know, like oftentimes a major refactor really speeds things up, right? Or really gives you the velocity that you need or really removes sort of quality problems that you might have in the product. But often they're just hard to communicate why and how and when and how much and sort of that quantification really ends up being, but it's sort of uniquely, I think every part of the business has, quote, technical debt. You can look at sales or marketing or finance, and they have their own version, if you will, of technical debt. They wouldn't call it that, but they certainly know the weak spots in their own processes, their own organization, and they just don't have time to fix them. Right? We always have that next thing we would like to be able to do if in a perfect world that, we just can't do it right now.
I know that, when we were preparing for this conversation, that you had some experiences that go back to the 90s of dealing with other people's code bases. Could you share a little bit about that story? I think back in the 90s, you were working on maybe, I think it was something related to the emergency services or trains.
Yeah, absolutely. A quick funny story. I've probably got a million of these, but, sort of unique story. I was working in the 90s I was a contractor as a software architect working for a large train company. And critical infrastructure. And I worked in, back then they called it, there was a sort of massive transition from the mainframe to what they called the mid-tier, sort of client server, mid-tier kind of system. And I worked in the mid-tier group. I was a software architect for this very, very large train company. And they were merging with another very large train company. CSX was the train company I worked for as a contractor, and they were merging with a company called Conrail at the time. So another Eastern Seaboard large train system. The way the train works, you have these mile markers. So every time the train rolls down the track, you see these little signs. Well, what those do is they send out a message effectively back to the central office. You can imagine all kinds of interesting things. It's just basic, simple math, elementary math that you can sort of understand how fast the train's going, when it's going to arrive. You can do all kinds of interesting things with that information. And of course, this business ran, a lot of the stuff that they do is a very event-driven asynchronous business. So a lot of the things, crew scheduling, all kinds of information. They had built an application. They shipped a lot of freight, right? So obviously they shipped cars as an example. So a car manufacturer, GM, could put in a VIN number if they wanted to know where it's at, when it's going to get to the next destination, et cetera. So really cool sort of set of applications once you have this sort of basic infrastructure, even though it's a fairly old technology. In the merger, what was happening, the merger was in process. We were switching their IT systems into our IT systems. And then, of course, that's not just sort of the virtual systems. We're also shipping physically the trains. The trains are now on, it's a shared infrastructure, at least in the United States, that all the different sort of public and private sort of use. And so this information was pretty critical to not just the physical company and the physical movement of our trains, but also Amtrak and, lots of other people. That sort of sets up the condition. The train merger had happened. We were bringing on these new trains into our system, and the system was falling behind and everything, of course. So you can imagine it's an event-driven system. If the events aren't being processed, what happens? Nothing. And, this is a union. It's got lots of regulatory. Trains are considered critical national security infrastructure. So whenever they don't work, everything sort of breaks down. Things were starting to really break, and I got called in as part of a team of people that were on call to figure out what's happening. Mainframe, mid-tier, all kinds of different people came into a war room to figure out what was going on while we were falling behind. And it wasn't a system I worked on before, but I was part of the mid-tier group, and I was assigned to go kind of work on this as a troubleshooter. We found out that as we traced the system down, we found out in those days we had centralized source code control systems, unlike distributed systems we have and enjoy today. Everything lived on a central server, and everybody checked code in and out of that system, so it was highly controlled. Well, this software by this group that interfaced and moved the data, from the beacon and into the sort of system, the source code didn't exist. It wasn't in the source code control system. A little bit of a problem when we're having an emergency. So what happened was we've sort of found out that we'd outsourced this to a company that had in turn outsourced to another company. Typically happens in these larger companies. The group that worked on it was sort of disbanded and no longer available, and we didn't have source code, but it was failing. It was rated to do a few hundred messages per second, but we were seeing over 1,000 peak, and so what was happening was we had no source code. We had a system that was failing. These were Sun microsystem computers back in those days. It was Unix. And so we were trying to figure out, how do we maintain that? How do we fix it? It's an emergency. We have the president now that's being, the sort of White House and all the sort of national security infrastructure, because now we're potentially going to impact a lot. And this small team of people had to sort of figure it out. I was representing, we sort of, once we diagnosed it, it's not a mainframe problem. It's not a database problem. It's not these other problems. I have to fix it. And I was told I have 24 hours to fix this, or lots of bad things can happen. So what I ended up having to do is I ended up using a Unix utility called Strace, pretty popular out there for those Unix people. I had to sort of look at the binary and sort of the network traffic. I had to use a hex dumper to sort of decode all the traffic and figure out what the packets were being sent. What was happening was it was forking, every message was forking a Unix process to send this via a CLI versus using sort of an API. It was an IBM MQ series back-end messaging infrastructure. I had about 24 hours to basically learn this third-party C API, decode these messages, which we had no source code for, reverse engineer them, rewrite it so we could get peak 2,000 messages per second, and then get it all in production in less than 24 hours.
Wow. I imagine that, outside of, needing to go through that whole troubleshooting process of reverse engineering things, is that something you're able to do with a pretty decent sized team, or we're talking a few people, just yourself?
No,
wow.
Just myself. That was the other problem. We didn't have source code. It's not really a multi-person job. I mean, we had some other people that were willing to help, but, how do you sort of do this? I mean, a couple other people sort of helping me help troubleshoot it. But at some point, it's just sort of you got to buckle down. You don't have a lot of time. It's not a sort of team sport when you're in that sort of scenario, right? So I sort of cut my teeth in the Navy. I was worked on the flight deck of an aircraft carrier. I was a troubleshooter. So I earlier in my career, so I sort of learned from the Navy how to make quick life-saving decisions, life-altering decisions on the fly. And so I was able to use those skills to quickly both write code really fast after I figured out how to decode it. Obviously, I had other people that helped me code review and test and do all the other things that kind of go alongside that. It was probably a 4,000 or 5,000 lines of code. It wasn't tiny, but it wasn't going to take days and days and days to write it, luckily. The hardest part was just sort of just decoding it, and we didn't know if it was right or wrong. We had to sort of test it, if you will, in production, and that was pretty quick.
Wow. That's a great story there. And I'm curious how often you probably have referenced that over the years and stuff. And it's like one of those early on. How far into your career at that point were you as a software engineer?
Yeah, so I'd been, I'm a little probably unique. I'd been doing software development. I was in my, I was probably 27, 28. I'd, been probably 10 years almost, not quite 10 years into my professional career. But, I started doing software development when I was 12, so I probably go back a little bit, maybe unprofessional, but, I've been doing software development and game development and even building. My parents owned a business when I was in high school, and I wrote a lot of software for their business, for the Mac back those days. So I've sort of unofficially been doing software development, probably still even at that time for quite a while. But this was sort of the first real, critical, what's the metal look like?
Right. I know currently you've been running Pinpoint for a number of years. What prompted you to go up and start that? I think you had previously maybe exited after an acquisition.
Yeah, this is my fourth venture-backed startup. So a software sort of startup that raised sort of venture capital. My previous company was a development platform company called Appcelerator. We made the popular Titanium mobile SDK, and we sold that about almost 4 years ago now. Partly I like to focus on problems that I uniquely understand, and Pinpoint is very similar. Appcelerator is the same thing. We wanted to build mobile apps, and we didn't know how to write Objective-C. So, I could learn Objective-C, which I of course had to do to build Titanium. But certainly I felt like there's millions of developers out there that have amazing web skills, and they're going to go learn Objective-C. That doesn't make any sense. So those are the types of problems in the businesses I like to create, or sort of uniquely I understand them, and I'm the target audience. And so Pinpoint was born out of the same idea. Was we got to be a much larger company at Appcelerator. And even though I had written all the original software and had grown the company, I just didn't still kind of know what was happening in engineering. And I felt like engineering was still this sort of mysterious black box, and there's all these moving parts. And I just always felt like there's got to be a better way to build and execute engineering. And we had sort of parallels. As a business person, I had parallels in sales. You had a sales operations team, and marketing had a marketing operations team. Finance has a finance ops team. And I always felt like, why doesn't engineering have sort of this engineering operations function? It's sort of orthogonal, if you will, to sort of the execution of building software and executing against innovation and things like that. But it was sort of a similar thing to sales or marketing, where it could come alongside engineering, help engineering be better, help it with best practices, with process, with data analytics. How do we sort of use data to make better decisions like we do in these other areas? And even among this sort of amazing creative process, this craft that we have as sort of software development, there's still an amazing amount of data that you can use, especially to figure out what you work on and how long is it going to take and what are the risks and things like that. And so that was sort of the concept of Pinpoint, was like, maybe different than we've had, 10, 15, 20 years ago. We don't have centralized source code control. We have a lot of our data in the cloud. We have more and more systems inside the engineering development stack, right? We have your CI, your CD, your source code, your Jira data, every day there's a new system inside of engineering that creates and leverages data and some sort of part of the process. But none of that's sort of used to help you itself build the software. It's all about the specific technology to help you deploy or help you build or write or whatever. But how about the process of itself? And so that was sort of the idea of Pinpoint.
Interesting. And as far as I know, I was doing a little bit of research on Pinpoint. It looks like you have a solution package that kind of helps integrate those systems. How is that helping teams try to make more sense of what's actually happening and better help them think about what they think might be happening in the near future?
Yeah. So, I mean, our sort of thesis was if we could take all this data. I mean, my sort of belief is that we have this sort of engineering information disorder, right? So we have this sort of it's a deficiency where all the information is collected either in lots of little systems or in people's heads, usually mostly in people's heads. And so the problem is, if we all had all this collective information, we'd probably make similar decisions, but we don't. I have a little bit of information about what's happening in production. You have a little bit of information about what happened before we rolled into production. A bunch of other people have a bunch of information, the impact on customers, et cetera. So there's all this information is there. It's just fragmented and it's unevenly distributed. So my thesis was, if I could bring all this information to a single piece of glass and then use machine learning to contextualize a lot of information, and then everybody could sort of understand and see what was happening and participate in that very transparently, the sort of just that alone is worth, valuable things to the teams that are building software. And I can really come alongside and help the people that are building software build software better. That was sort of my mission. How can I help the development teams? Because the truth is, there's a lot of things that happen as a software development process that really don't help me as a developer, right? I mean, if I'm writing code, I know I'm writing code. Like Jira doesn't know I'm writing code. Other places don't know I'm writing code. Maybe my development manager, my product manager, or all the people above them don't know that I'm writing code, but I know, right? And sort of Pinpoint would know, right? Because we know that you've created a branch, you started working and creating a pull request, and we sort of know all this activity. So it's sort of like, how do we come alongside and really automate a lot of the things that developers have to do that really are for the benefit of other people? And those are important things. Don't get me wrong. That information is important to other people because they're making other decisions based on that. But then also help me. And so it's sort of like, how do we come as an example? How do I come alongside engineers and give them things that really automate that sort of process and help them run and execute and really, frankly, do what they love to do, which is write software and solve problems, but gives that information, gives that context, helps other people understand risk and forecast and prediction and things like that then help them advocate back and communicate and help prioritize and help understand those business trade-offs that engineering often is faced with. And so that was sort of the sort of how we sort of do it. So the way we do it is we pull all the data in across all kinds of different data sources. We build a canonical, if you will, engineering model. We understand everything that's happening inside the engineering process, kind of independent of your physical process or independent of the source of data. And then we leverage machine learning, artificial intelligence to sort of really build on top of that. And then we provide a set of tools for those people to really execute better.
So is this more than just providing some current engineering data reports on like, here's how much work has been done, or is this helping communicate on behalf of the developers to stakeholders? Or is this something that like it's for primarily for developers and say their stakeholders to have a shared set of metrics or what have you in progress on projects?
Yeah, that's a good question. Yeah, so I would say that we sort of break it down into three distinct personas. There's the individual developer and development teams. So that's our primary focus is how do, they don't care about metrics and all that reporting. That doesn't help them do their job. What they care about is how do I effectively plan the sprint? How do I effectively execute a retrospective? How do I know this issue is being impacted by another team and is going to impact my ability to deliver the sprint on time, right? It's sort of information contextualized that helps them understand what is Jeff working on that's different than Robby and different than Shannon, because we're all working together. And by the way, we all have to deliver software together at the end of the day. And where is Robby really overwhelmed right now, but he's not going to raise his hand because he's a really good team player and he's working his ass off and working overtime. But boy, Shannon right now is working on some lower priority things that if I knew that, I would move it over to Shannon because she could work on that. And frankly, she hasn't worked on this code base, so she maybe should learn and sort of would be good skills to learn because she needs to be able to take this on. So that's the type of things that we can help individual developers and individual development teams with. It's really about how do we better execute the things that we're working on and keep us into delivery than sort of the tools that we use. Now, obviously, once you do that, all that information becomes really informative to other stakeholders. For example, VPs of engineering or VPs of product, or frankly, even CEOs and CFOs, and sort of other stakeholders in the organization. Because at least in software-driven companies, it's not like marketing some other function that has no impact on product or engineering, right? I mean, I'm doing a huge campaign. We're doing a huge launch on a new set of features in 2 weeks. If it's going to slip, it has tremendous impact into the campaigns I'm going to run, when I'm going to deploy this, my priorities, how I'm going to spend money and all that. And so often those are not obvious, right, to both sides, right? I mean, it's and what we do is we spend lots of meeting time and energy and talking and making, estimations, and we're almost always wrong. So the goal is like, how do you raise that information up to empower and self-service that information to all those other stakeholders? Yes, one part of it is like, well, how do I make better trade-offs? I'm the head of engineering. I've got 10 Scrum teams that are working on a set of really high priorities. Well, when things are changing in the business, how do I understand how to help the business understand what those will impact and what I can do and what we could potentially move, and vice versa? How do I then communicate back to those engineering teams and really advocate and understand, why is it taking longer? What's the impact? And obviously, I don't do that in isolation. I mean, no amount of data is going to give you that information. But boy, if I have a lot of information that's happening, if everything has to be a meeting or a set of conversations that are interrupt driven, if I had that data, I could do a lot more of that information myself, and I could be a lot smarter about that.
Interesting. Is it safe to assume that at Pinpoint you're eating your own dog food and taking advantage of the product yourself?
Oh yeah, I mean, that's the cool thing about working at Pinpoint. I'm sure it's like working at Slack, right, or any of these kind of companies that you're your own best target. I mean, and that's sort of part of the challenge. I mean, we're building Pinpoint for ourselves. We like to say we're customer zero. We're eating our own dog food. We're building Pinpoint with Pinpoint. We're trying to be way more visible. You'll see a lot more of this in the next few months about just how even our own data and how we operate even with our customers, so they can see our own Pinpoint, how we're doing. So we're not just trying to be, sort of use it for ourselves. We're also trying to sort of say, like, for our customers, our stakeholders, you can see what we're focused on.
Interesting. What types of metrics does your engineering team measure on a regular basis?
Yeah, usually it's most on the engineering side is usually around things like how cycle time, as an example, how long, different teams are different, right? So we have three kind of teams, what we call full stack teams. So three of those we use sort of the Spotify squad model. So we have sort of guilds of sort of a data science guild, as an example, that are all the machine learning data science people. We have a front-end design guild, sort of the people that are more design, UX, UI people, et cetera. But people are organized by full-stack teams. So one team has every specialty in that team, and they can operate autonomously, and do kind of the whole full stack themselves. They do their own deployments. They do everything themselves. So they're not dependent on, we're trying to sort of reduce the east-west communication and do a lot more north-south communication, which is in the Spotify model. So back to the measurements, so each team is different, right? Some teams have very, very fast because types of work they do and sort of the composition of that team. And so we sort of look at things like lead time or cycle time as an example, because that helps us understand planning wise, like if we're going to give a certain capability that needs to be done at a certain time, which team do we give it to? We also look at sort of their activity over the 2-week period typically. So we have some pretty cool things we can show. We integrate with calendars so we can sort of understand sort of how the team works, when they work, things like that. The team really usually isn't super focused on metrics because really it's more about, like the metrics are ultimately in the outcomes. What helps at the metrics level is really more when we roll it up. When I look at it, when my head of engineering looks at it, when my head of product looks at it, and when we're really more focused as a team on planning, is really where metrics really help. Or like, for example, in the last 4 weeks, our velocity has increased dramatically. And so, obviously we're working from home. So our first, 5 weeks ago, when we first really started doing this in earnest, we worried a lot about what was this going to do to communication. We're a startup, so, working from home is not a big deal for the most part, but you never know, right? I mean, it's not just about working from home. It's like the impact of health and mental health and like, just sort of all those other things that we hadn't really experienced. We're not a purely virtual company, so we hadn't experienced those. But it was interesting to sort of see this like velocity increase over the last 4 weeks, and also the correlation to fewer meetings, more planned, activity. So less ad hoc time that gets kind of wasted, if you will, in the system. Walking to work, commuting, walking to lunch, those are all good things. So I'm not trying to sort of say those are things we want to get rid of by any means, right? Because those service a different part of the organization or the human being. But it's sort of interesting to see how that impacted our numbers and how many more things we've been able to get to in the last 4 weeks.
It's interesting. For those listening, there might be a little bit of a lapse between when we record this and when this will be published, but we're talking like at the end of April right now. And so it's been, I don't know how many weeks now. Has your team been home now? 7?
It's our fifth or sixth week. I think we started in March, so I guess technically maybe it's almost our 7th week or something. Yeah, it's in the middle of this COVID crisis. It's crazy.
It's interesting for you to see some upside to your team's velocity in some ways, but I'm assuming you're not just making an assumption that that's something you can continue retaining at that sort of level.
No, and frankly, that's a good point. I mean, that's actually a good point because we've actually had a lot of discussion. I mean, two areas of inflection. One is like we started building some sentiment stuff into our product around sprint retrospectives, and so the team can talk about like their performance may be killing it, but maybe they're burning out because they're working 7 days a week, right? Or they're tending to not be able to like do some of these other activities that while they may be happy that sort of like it's impacting their health and well-being. So raw performance is terrible by itself as an indicator. You have to sort of bring the whole person into. So that's a lot of like the types of things we're trying to look into. It's like, how do you balance the qualitative and the quantitative? Because as a CEO, certainly as a head of engineering or a CTO of a company, I mean, I care as much about the health and well-being of my team as I do their raw output.
We'll be back with our interview with Jeff in just a moment. Hi, it's me, Robby. I want to take a quick moment to thank you for making time to listen to Maintainable. If you're finding these conversations valuable, please consider sharing a link amongst your peers and writing a review on Apple Podcast or Stitcher. Also, if your team uses Ruby on Rails and is struggling to keep up with more recent versions of Rails and overdue for a upgrade at some point, and are maybe even considering outsourcing that, I think we should talk. Get in touch with us at Planet Argon, and we can tell you a little bit more about how we're helping teams help themselves figure that out so they aren't so dependent on outsourcing that type of project to an external development team. We think you should be handling this yourself, and we're happy to help you do that, and we've got some strategies on how to make that happen. So get in touch with us at hello@planetargon.com. And now, back to our interview with Jeff Haynie. I'm curious about what sort of, over the years and different teams that you've overseen and been part of, what types of metrics do you still hear people talking about in our industry that you've since kind of taken a stance of, I didn't find a lot of value in that at the end of the day. It was like something we were tracking. I'm thinking of things like code to test ratio or code coverage.
Yeah, lines of code. Yeah, I mean, code coverage, I've always felt like that was a very elusive metric. It's one of those metrics you feel like shit because you look at it. It's sort of like, it's like, you're overweight, you need to lose 20 pounds. Ideally, you'd sort of have a regimen that'll help you lose 20 pounds. And sometimes that's super possible, right? Sometimes you have a medical condition and that's just, you have diabetes or whatever. And it's just sort of not practical to sort of be a marathon runner. And so I think sort of code coverage, a great example of that. It's a great metric. I'm not sort of disparaging it by any means. It's just one of those metrics that sometimes it doesn't really matter. It does. In a perfect world matter, you'd have perfect code coverage. But I've been in certain cases where we really focused on code coverage, like, Visual Studio Code. We write a lot of Go code. So Visual Studio Code and Go has a really good set of integrated tools around that show you for a file or a package, let's say, with the code coverage. So we spent a lot of time at one point in the last couple of years really trying to get that at 80%, right? And just, fixating on that number. Meanwhile, we had scale and quality problems in some of that same software. So on one hand, we felt really good, sort of as one of these, like, we felt really good because we had written, and we in fact, we were writing sort of artificial unit tests to make sure we got over the 80%. And it felt good, but it was sort of one of those vanity metrics where it really didn't really ultimately impact my outcome. And I think we can kind of look at a lot of those things. So lines of code can be very similar things or numbers of commits. Now, that being said, I think like any data, like there is a point of view, right? I mean, it's like if you had zero code coverage and zero, you could make a pretty strong argument that maybe there's technical debt or code quality problems there. It's sort of like, it's like a lot of these things aren't binary. It's a lot of shades of gray. Same thing with like lines of code. If normally my volume of code and PRs on a week-to-week basis is generally within some band of normalcy, and then all of a sudden it drops off. Now, it could be that we're on PTO or we're on extended vacation because we're in Europe or we're on an offsite, in planning. I mean, there could be totally normal statistical deviations and why that's happening that you would say, absolutely, I would expect that. Or the inverse is true. If you expect people that are on PTO have a lot of PRs and code, they're maybe getting burnt out because they're not taking time off, right? So with this information, the right people will be able to contextualize that information and make good decisions. I mean, I trust engineers, I trust engineering teams with better information. They know their context, they know their environment, they can make good decisions. Often it's just they don't have the context, they don't have the information, they didn't understand the business reason. Often it's those things that are really what hold us back usually.
Yeah, I'm always curious about like what types of metrics teams are finding some good value in that could be helpful for reporting or reflecting on. My own team struggles with this at times. We're like, well, how long does it take to get like a pull request on average to get closed or merged or what have you?
Yeah, that's another good one we use. We actually do use time, to merge pull requests because we find that if a pull request sits more than like 24 hours, it starts to get a lot of merge issues, a lot of additional work that has to get done that wasn't tied to the original pull request. The other thing that we get, if you have pull requests that last more than 2 or 3 days, is often that's a sign of, and these usually are in combination, but that's often a sign the pull request too complicated. Like we didn't break the change down small enough that makes it easy to review. And so what tends to happen is reviewers feel like they don't fully understand it, or they need to have more people look at it, or it's, I got to get back to it later because it's not like 20 or 30 line diff. It's like 15 files and 1,000 lines of code change. Now, we can't always avoid those, right? I mean, oftentimes you have to do those. I mean, you have a big change or a big refactor and you need to do those, right? But in general, we like to keep pull request time really, really tiny. And so like the velocity is really high. So we actually look at how long the pull request is staying open and how many are we doing as sort of a total, as just a directional indication. It's not an absolute. I'm not going to fire someone or saying you're doing a bad job because you've got a big pull request. I understand, but I had a conversation 2 days ago with an engineer. It's like, this thing's been out there for a week. Why? And it's like, well, I don't feel like it's quite ready and it's kind of complicated. And I feel, and it's like, no. You need to break this down. We need to do this in 4 or 5 pull requests over 4 or 4 iterations. We're a very feature flag heavy company. So everything we do in our software is a feature flag. So it's like, no, just roll this thing out behind a feature flag and let's catch it in the next 1 or 2 pull requests over the next couple of days.
I think that's a good suggestion there for those types of scenarios. I'm always like, even with our own team, when we're dealing with that sort of problem, there's usually an indicator that the pull request is too complicated and the other people that are looking at it just don't have the time yet to get their head wrapped around it. and they're like, they know they need to give it time, but there's not always that initial inclination to be like, hey, this is too complicated for me to maybe be able to get this done in a day. Like, what can we do at that point? So thinking about how peers can negotiate that and talk through that, or I don't know if there's enough conversations also around in our industry, because I haven't seen a lot of it, but it's like in terms of how to present a pull request or to submit one, like here you can come up with templates and guides for what you want in those things and how you can go through and test this yourself, where you've been testing it and how you're approaching this, but also I haven't seen a lot of people take a couple steps further to do a lot of training around how to receive feedback on your pull requests in an effective manner. Do you have things that your team has kind of been able to do?
We do. There's a few things we do. I mean, and our inflection point was a few months back. We had a developer that was really, really top developer, and we were seeing a lag in productivity. And we talked to her and we said, what's going on? And she said, look, I'm spending half my day. We have one of the people on her team is in Europe. So sort of, adjusted schedules, right? She says, I come in and Chris works all night and all these PRs, and then I spend half my day reviewing his PRs, right? And I'm the only, she's not the only person, but I mean, her feeling was like, I'm spending all my energy just doing PRs. And that was a good example of like, we need to round robin these. You shouldn't be doing all these PRs. I mean, she was doing it because she felt obligated, right? But it's like, there's a lot of other people. And number one, we need to spread this out. Lots of other people need to, it's a training opportunity to like review PRs and provide comment and understand how it's working. To your point, it's a bi-directional thing. It's not just hey, review my code and let me know. It's also hey, why are you doing this? And, I didn't realize we could do this or that. So we've really, what we do, we changed. What we now do is we actually encourage people outside of that specialty, what we call the guild, to review those PRs. So obviously we want a person a peer of that sort of specialty. If it's a data science thing, we don't want a front-end person by themselves to solely review something that maybe they don't understand. But we do encourage that so that it's a learning lesson and it's a way for them to understand other parts of the system. And we found that to be really good. The sort of second thing we've done, we do have every project's a little different, but we do have a pretty significant template per repo that we create. As an example, on the web app, kind of our front end part of the app, it's got a pretty detailed set of checklists. Does it have a launch darkly flag? Please include a screenshot. Here's a link to the preview. We use Light preview links. Here's a link to the preview. We do a lot of this stuff to make it easier for people to sort of checklist their PR and then also give us feedback through that process. We also now, with Pinpoint, one of the cool things about Pinpoint is if you use something like Zide or any of the other sort of preview systems, Netlify, we pull that data into Pinpoint. So when you're in Pinpoint and you're looking at issue and you're looking at all the PRs, we actually provide you the link. We extract all that data out of the PR. We provide you the link. And so what we've now had, which is really cool, our product managers, our head of engineering, other stakeholders can go use the PR. If it's a web app PR, they can use that PR in the preview mode before it's even merged. And they can actually provide content feedback or even functionality feedback. So it's not just the development code review. It's also now more of the functional product sign off on it. It's actually the quality of our code has gotten better because we're giving that real-time feedback, and it's reduced the amount of time of like we merged it and then now product's playing with it and now they have this feedback and we got to create another PR to incorporate that feedback.
Right. So does your team have your is that QA or UAT type stages? They're putting in suggestion changes on the PR level versus a new ticket?
That's right. Yeah, we don't have a formal QA team. We don't have, we depend on product and every person in the company to use the changes before we merge them. And we've just made that super easy to click on at least on the app side. Obviously, not everything has that. Certain pieces, aren't, our data science pipeline, you can't click it and run it, right? I mean, it's a little bit more complicated, so it doesn't kind of work on every part of our stack. But certainly the pieces where you often give the most feedback is usually the things that are more visual or functional in nature, and those usually tend to be in the application. Often you'll see PRs that might have, they'll have a set of screenshots. You'll obviously have this link where you can actually go run it and use it. And you can also point it to different environments, like you can point it to our stable environment versus our edge environment, et cetera. And then you might have 40 or 50 things on that PR of giving feedback that aren't code related. Obviously, we have code related as well, but often it's, hey, this left thing is really messed up and then we should move it to the right, or this doesn't quite look good with this color. And usually it's that functional feedback that often gets captured longer, or I should say later in the process, that becomes a lot of churn you have to do.
Nice. Do you, if you reflect back on your experience in the industry over the last few decades, we have tools like Pinpoint and all these different platforms and tools that software developers are interfacing with now as part of their stack of just the kind of supporting tools. Do you believe that it's more or less complicated now to kind of become a developer and come into this world than it was 15, 20 years ago?
Yeah, that's a good question. I think a lot about that, actually. At Appcelerator, we didn't have a no-code or a low-code product, but we were spending a lot of time talking about that direction. Is like, how do you get to a sort of more drag and drop and sort of, citizen developer sort of concepts or whatever. And I do think in one hand, it's so much easier these days to get in, like learning React and learning Get. And while they are relatively complicated technologies, thinking about, at least for myself, I did Pascal for a number of years. I mean, they're so much more approachable in all of the infrastructure around. So yeah, on one hand, you have to sort of learn a bunch of things and jargon and how it all works and pull requests and all these sort of weird esoteric things. But on the other side, I do think generally, once you kind of get over that curve, it's actually so much easier to be a developer. I mean, to be able to clone a repo and literally have it running and push to the cloud. I mean, it's amazing what you can do today without having to have a huge amount of infrastructure. I mean, several companies ago, the first, $4 million we spent in the first 6 months was building out a data center in level 3, ordering fiber, getting the cabinets, buying the servers, having someone come in and wire it all up. I mean, you spend the first 3 or 4 months before you write one line of code, really. I mean, and today, I mean, you and I could come up with something on a hackathon. We could have it deployed in 15 minutes and have millions of people using it an hour later. And so I think in a lot of ways, yeah, there is an increased amount of complexity, but on the other side, it's also a decreasing amount of complexity. It's an interesting dichotomy, actually.
Yeah, I think that's interesting. I'm always curious about how developers coming into this industry in the last few years and not only needing to learn about how to just program on an application or build an application, but usually you're working on making changes to applications, adding new features and stuff like that. But then to also understand like how these different tools all kind of interconnect and like what's the work process for being part of a team now. I think it's probably a lot different than it used to be. And as we hire junior people, I can see them going like, oh my gosh, there's so many things to learn. And I'm like, it's okay. You'll get there over time. It's just be patient.
That's right. And we feel a lot of like that's our mission. I mean, that's been my mission in life. I mean, I've been working with developers and development tools and all this for a long time. Obviously, we're not building another framework or we're not building another thing for deploying. This is a different thing that I built in the past, but it's still along the same sort of general religion, which is like, we just got to make this easier and better and faster, and we got to be more empowered. And that's just been my mission is like, how do we do that? And I think, I think this sort of COVID crisis is interesting because I do think, and not just in technology, I think this sort of rips across the entire sort of stratosphere of all sort of companies, distance learning. I mean, sort of everything gets kind of rethought in this new model, but certainly engineering, we've been toying on this idea of distributed teams and remote teams and all this for 20 years now. And there are companies that do it, the Zapiers, the WordPresses of the world that sort of are all fully remote. But if you still look at most companies, even ones that sort of allow remote work or hire remote teams, they're still mostly a centralized, Facebook still mostly is in 1 or 2 or 3 areas, or Google, or, most companies. I think what's interesting is now if we get used to sort of this new mode of working and with all these new tools that are available, what happens, right? I mean, really, can you truly have a distributed workforce kind of team? I mean, there's amazing talent all over the world. I mean, and not all this talent could be captive in San Francisco or New York or Austin or whatever. I mean, I think that's the other macro opportunity. And I think it's going to require tools and community and things like that to do this.
I don't know if you had an era of your career where you were involved in like local user groups, and that might look a lot different now. Like proximity based meetups?
Yeah, I think it will. I mean, at UpC, we had at one time at our peak, I think we had 60 or 70, meetup groups worldwide that met. And so I spent a lot of my time for a few years just traveling around the world, speaking and meeting with user groups and, just sort of all the things that, that you do as sort of a big, large open source community. And yeah, I think about that right now as like, those are still important. I mean, meeting people for all the social reasons we've talked about earlier, those are all still very important. I'm not going to try to take that away, but does it change? I mean, like with things like Zoom and Slack and, more increasingly, it's so much easier to work in these sort of asynchronous environments than, and frankly, it's just more productive in some ways, right? I mean, I can meet with talent all over the place. It doesn't really matter anywhere you're at. That's what I think is pretty interesting. There's still real structural problems you have to solve, like time zones, but, I think with tools, it becomes a lot easier.
I have a couple last questions for you, but one thing I wanted to touch on a little bit, because you mentioned it earlier, was about how your tool's using AI. How do you believe AI and, say, machine learning is going to be impacting our industry and our process of writing software, maybe more specifically in the coming decade or so?
Yeah, I think a lot about that. I mean, I think the sort of the first wave, if you will, or phase, which is I think what we're in, is this sort of how do you use data and learning to augment the process of building software? How do you make smart people smarter and more informed? I like to use the analogy of Google Maps. 20 years ago, it was not uncommon to memorize directions or phone numbers or or even frankly, if you're going to somewhere new, you bought a Rand McNally or whatever, right? You ask directions, right? The proverbial, men don't like to ask directions kind of trite sort of saying, but today we outsource that to Google. Right, we still have that functional capability in our brains to do that, but I would probably argue we've reduced that functional capability in our brains. I don't remember phone numbers anymore. I don't remember driving directions. Frankly, I don't care. I just let Google remember that for me. And that's sort of a good example, I think, in phase one. I think software development will be very similar. So I think the days of sort of there's sort of these sort of tasks, I think, is software development where we try to keep all this stuff in memory, that I think, the first phase will be how does it come alongside and really help the developer be more productive and remove a lot of those things that I just don't have to worry about anymore. And my example is like, it knows that I'm working on stuff, so it should just know that I'm working on stuff, right? And it's sort of like the Tesla. If I get in and I have a meeting on my calendar and it's got an address, it just sort of knows where I'm going. I don't have to sort of bang on the keyboard and sort of tell it where I'm going. It kind of knows that. Sort of this sort of ambient computing sort of is, I would say, sort of the first wave, and software development will be a similar thing. And you could use that as like autocomplete and like a lot of the things that we're trying to do at Pinpoint, right? Is like, how do I make the developer much, much more productive? And frankly, I live a much more interesting life by doing that. I think that's phase one. I think sort of phase two then becomes, okay, how does AI start to actually do generative and write software for us? And again, it's not going to replace a developer. It's just going to take a lot of those tasks. And we're already seeing some of this, right? I mean, a perfect example I like to use, and a really simple, if I'm on GitHub, or let's say I use Sneak, and there's a CVE and my software is impacted, it will automatically create a PR for me, right? I mean, that's a great example of like, even in the phase one of like the software's come alongside me. I could, of course, go do all that myself, but the software can do that for me. It doesn't, I don't sort of need to do these sort of mundane tasks. And that's a sort of a form of writing software. I think that'll get 1 or 2 or 3 orders of magnitude more complicated. And sort of you're seeing that with self-learning and sort of adversarial networks and sort of things like that, where, initially, it couldn't beat a Go player, and now Go players are learning how to play Go better from AlphaGo, right? It's not just they're learning how to compete, they're actually learning themselves how to get better. And I think we'll do the same thing as software developers. And then, of course, who knows what happens beyond that? Will sort of machines themselves write software and become, self-aware? Who knows, right? Probably, but who knows?
I feel like it's always been like a conversation in our industry for, at least I've only been around in the industry for a couple of decades now, but there's always this kind of like, well, is this going to mean I'm going to write less code in the future? And I don't think it's quite manifested that. We're just writing different types of code, and we're not reinventing the wheels that don't need to be reinvented again, which is really helpful.
It's really cool.
So a couple of quick last questions. What non-software development related book do you find yourself most often recommending to people in our industry?
Well, the best one I would recommend right now that I pulled out and started rereading, and we have a book club internally that we're starting to read as a company, is sort of pertinent to the time, is the best thing is about worst things. It's Ben Horowitz' book. I always get it backwards what it is.
Hard thing about hard things.
Hard things about hard things. Sorry. Yes, Hard Things About Hard Things by Ben Horowitz. I mean, Netscape, A16Z founder, LoudCloud. He kind of wrote it in a couple of decades back in the .com days, but it couldn't be more relevant today. And sort of this notion of a peacetime and wartime CEO and how sort of the organization thinks about, growth, amazing sort of bull market to maybe now we're shifting to maybe potentially a bear market, global sort of change, what happens. I think it's a really great book, especially for software engineers, because I think a lot of it's written from the standpoint of a founder, CEO running a software company, but all the sort of hard decisions that have to be made that aren't always obvious from a pure product technical engineering standpoint. That's a great book, I think, to pull off the shelf. If you haven't read it, go read it. If you have read it, pull it out and reread it again. It's amazing.
I think I bought it on my Kindle a couple of years ago and I didn't get too far into it. I need to pick it back up again. So thanks for the reminder there. Where can listeners best find and follow your thinking? And
so on a personal level, Medium, .com, Jay Haynie, sort of at JHAYNIE is my Medium. I don't blog as much as I used to, given that seems like a harder and harder form. So that's sort of what I do try to write there. Obviously, my Twitter, I share a lot, same handle, twitter.com, Jay Haynie. And then, of course, pinpoint.com. We've got a world of information I write about there and videos, and we have a YouTube channel and Slack community and all that as well. So much more, obviously that's not all corporate because we write it and talk a lot about things that are appropriate to all software development organizations independent of Pinpoint itself.
I think it's great that you and your organization are helping contribute back out into the community. And you reference like Spotify's squad pattern that they're using with their teams there. And I think we learn a lot from each other. We also learn what doesn't work for us sometimes too. So I think that's always really helpful to get different scenarios and different experiences to share, which is why this podcast, I'm just trying to talk with a lot of similar people in different roles, but similar topics, but everybody has a different angle and twist on it.
Well, this is how we learn. This is how we get better, right? As a human species, certainly as a profession of software development. I mean, there's so many different things you can learn from each person and each team. It's for me, that's why I love doing what I do. And I still write software that's just the most amazing thing is you can create something with a lot of different people and you can kind of do anything you want to do.
Well, it's been such a delight having you on Maintainable, Jeff. I hope that you and your team and everyone in your world is happy and healthy as possible. And
thank you.
Thanks for joining us.
Yeah, thank you very much.
Maintainable.